Okay, so we have this problem and we are trying to solve this problem. So the problem is the overhead reach distances of adult females are normally distributed with a mean of 202.5 centimeter and a standard deviation of 8 centimeter. So we have to find the probability that an individual distance is greater than 215.90 centimeter. So to solve this problem, we have to find out the corresponding z value for 215.90 centimeter. So remember the formula for the z-score conversion. So this z equals to x minus mu over sigma, and here we have the x value 215.9 minus, and our mean, the mu is 202.5 divided by standard deviation sigma, which is 8, and 215.9 minus 202.5 give you 13.4, and you divide by 8, so you will end up with 1.675. So you are supposed to find the probability of this individual distance is greater than 215.9, which is equivalent to z is greater than 1.675. So that means if you have this is your normal density curve, and your 1.675 is somewhere here. This is your z value, 1.675. So you are trying to find out this area. So this area, the area of the shaded region, will give the probability that an individual distance is greater than 215.90 centimeter. So by using the calculator, you can find the area, this area, to the left of z equal to 1.675, so which is 0.9530. This area is 0.9530. So let me write down here, this is 0.9530, and you know that the total area under the density curve is 1. So to find the area of the shaded region, you have to subtract this area, 0.9530, from 1. So let me write down here. You subtract 0.9530 from 1, so you'll get 1 to find the area, to the right of z equals to 1.675. So that is 1 minus 0.9530, 0.9530, which is, let me find out here, 1 minus 0.9530, which is 0.047. So this is 0.047. Hold on a second, let me find out, let me double check this area. So you the second, the HRS, you go to number 2, number area, and the lower value is negative this, upper is 1.675, you hit enter, Okay, so that's gonna give you, yeah, 0.9530, and that will end up with 0.047. Okay, so this area, which is the area of the shaded part, gives the probability that an individual distance is greater than 215.90 centimeters. So this is your final answer. So this is your final answer. So now for the part B, this is the solution for the part A. For the part B, we have to let me write down the part B. For the part B, you have for the part B, you have find the probability. Find the probability. Excuse me. Find the probability that the mean for 15 randomly selected distances, 15 randomly selected distances greater than 200.30 centimeter. Okay, so to find the solution of the second part, we have to know about the central limit theorem. And note that the population here, the overhead reach distances of adult females are normally distributed. So the population is normally distributed, so we can apply the central limit theorem. And according to the central limit theorem, so let's do the solution here. Okay, so you remember the central limit theorem. So according to this theorem, the distribution of the sample mean, let me write down here, the distribution of the sample mean, the distribution of the sample mean x bar will have a mean given by mu x bar equals to mu. So in this case, your mu x bar is equal to mu, which is already given in our problem, which is 202.5 centimeter. And the standard deviation is given by sigma x bar, which is sigma over square root of n. And you know the sigma is given in the problem, which is 8 centimeters. So this is 8 divided by square root of this n is the sample size. And the sample size is 15. So 8 over square root of 15. So that will that will be 8 over square root of 15. So you can just like use the calculator to get the value of that. So 8 divided by second, okay, square root of 15. So that value is 2.0655911118, something like this. Okay, so now this probability, so now again we have to convert this into the standard score. So again, let me erase that first. So what you have so far is so we have mu x bar equal to mu, and which is 202.5, and sigma x bar equal to sigma over square root of n, which is 8 over square root of n is square root of 15, right? And so we have this, and then taking this mu x bar and the sigma x bar, we convert this into a z score. Again, remember the formula: z equals to x bar minus mu x bar over x minus mu x bar over sigma x bar, and we have this x value is 200.30 centimeter, and the mu x bar, it is exactly the mean, which is 202.5, and the sigma x bar, this 8 over a square root of 15, and if we use the calculator and do the little bit computation, so we will end up with negative 1.065. So this is equivalent to negative 1.065. So now the probability in part B is equivalent to the probability Z is greater than negative 1.065. So that means if you make a standard normal density curve, and you have negative 1.065 somewhere here, this is negative 1.065. So now you are supposed to find the area of this shaded region. So this region, you are supposed to find area of this region. So, and I think first you need to find the area to the left of negative 1.065. So for that you can use the calculator to find this area. So if you have a TI-84 plus TI-84 or 83 calculator, so to find the area to the left, so I am talking about this area, okay, area to the left. So this area, so you can use the TI-84 calculator. So you press second and the VARS, and you go to number 2, normal area, and then you fill up, you enter the upper value. So upper value is negative 1.065. So so if you hit enter, so you will get yes, so you will get this area equals to 0.14343 and let me round up. Okay, let me round up to 1, 2, 3, 4, 5 decimal places. So this area is 0.14344, but we are trying to find the area of the shaded region, right? Because this area of the shaded region gives the probability for the second part of our problem. So like before, what we do here is we subtract this area, which is 0.14344, right, from the total area of the curve, which is 1. So you subtract this area, okay, which is 0.14344 from 1, because you know this 1 is the total area under the density curve, right? So now what do you get? So you will get 1 minus 0.14344. So that will give you, let me subtract from 1. So that will give you 0.85, 0.8566 if you round to 4 decimal places. So this will be the probability that the mean for 15 randomly selected distances are greater than 200.30 centimeters. So this is the final answer for the part B. Okay. So this is the final answer for the part B. And excuse me, guys. Okay, so let's do the next problem. Let me erase that. So let me copy the problem first, okay? So the next problem is, I think I guess it's somewhere here. Okay. So the next problem is find the critical value z alpha over 2. So let me copy that problem. So the problem is find the critical value, z alpha over 2 that corresponds to the confidence level 92%. To the confidence level 92%. Okay, so let's solve this problem, okay? So now you have to know that the meaning of z alpha over 2. So if you have a standard normal curve and if you have a z alpha over 2 is right here, which is a z score, right? So this z alpha over 2 denotes the z score. It denotes the z score with an area alpha over 2 to its right. So that means this z alpha over 2 is the z score, and the area to the right of this z value, this area, the area of the shaded region, this area is alpha over 2. Okay, and you guys know that the confidence level, and remember, you know this letter alpha, this is the Greek letter, and you realize this alpha is a Greek letter, and you realize alpha. Okay, so guys, you have to understand this. The z alpha over 2, this is the z score, and to the right of this z score you have the area alpha over 2. So the area of the shaded part is alpha over 2. Okay, and so after you understood this, then we can solve this problem, which is very, very simple. And if you look here, so the confidence level is defined. Confidence level is defined as 1 minus alpha, and you see the confidence level is 92%. So you know this 92%, which is 0.92, equals to 1 minus alpha. And if you solve for alpha, so that's going to give you 1 minus 0.92, and you know this 1 minus 0.92 is equals to you know, this is 0.08, I believe, right? 1 minus 0.92 is This is 0.08. But you need alpha over 2, so you divide both sides by 2. So alpha over 2, you divide both sides by 2, so 0.08 over 2, which is 0.04. So now, if you look here, if you have a standard normal density curve is right here, and let's say you have a z, this is your z alpha over 2, which is g 0.04, and you are trying to find out the value of this z score, and you guys know that to the right of this you have a region, the shaded region, and it has the area, right? What is the area? This area is area, so it's 0.04. Okay, okay, but so to find this g value, you need the area to the left of z. And you guys know that the area under the density curve is 1. And this area to the left of z 0.04 is 1 minus 0.04, which is, I believe, which is 0.96. Okay? So you have a 0.96, and again, by using the technology, you can use the calculator. So I have a TI-84, so you can use TI-84 if you like. So you hit second, and you hit VRS, right? And then you go to number 3 for the inverse normal. And you guys know the area, which is 0.96. You enter that 0.96, and you hit enter, and you will end up with the value. This equals to 1.75. If you round up to 2 decimal places, so this is 1.75. So now the critical value z alpha over 2 is 1.75. So this is the g score. Okay. So now the final answer is 1.74. So this is the final answer. Okay. So now let's go to the next problem. Let me erase that first. Okay. So the next problem is, so let me copy that first, okay? So a drug is used to help prevent blood clots in a certain patients, okay? So let me write down here, a drug is used to help prevent blood clots in certain patients. Okay, in certain patients, and in clinical trials, among 4,743 patients treated with drug treated with drug, 188 on 100, oh, let me write down this again. 188 developed the adverse reaction of of nausea, and okay. to construct a 95% confidence interval for the proportion of adverse reactions. Okay, guys. So now the part A is find the base point estimate of the population proportion P. Find the base point estimate of the population proportion P, of the population proportion P. Okay, so you guys know that. So let's find out the solution of the part A. So you know that the sample proportion P hat, the P cap, whatever you read as P hat or P cap, it's up to you. Okay, the sample proportion P hat is the base point estimate, estimate of the population proportion P, of the population proportion P. Okay. So now let me read that again. The P hat is the base point estimate of the population proportion P, and we have the formula to find the P hat, which is X over N, and this N is, you know, like which is 4,743 in this problem, and we know that 188 patients develop the adverse reaction of nausea. So now you know the value of X, right, and is 188, and divided by the total number of patients here is 4,743, right? So now if you divide 188 by 4,743, so that's going to give you 0.04. So this is the sample size, and this is the success, right? 188 success and the 4,743 sample size. And if you divide 188 by 4,743, right, then you'll get 0.04. So this is the value of P hat, or this is the which is the base estimate of the population proportion. So this is the final answer for the part A. Okay, so this is the final answer for the part A. And for the part B, we need to, so we have to find the margin of error. Okay, so for the part B, let me erase that first. And you remember that we got a so let me write down the part B first. So this is identify the value, of the margin of error, Okay. I know that, guys. You find out. Okay, let me write down here on the side. So we got the value of P hat, which is I think like it's 0.04, right? Yeah, 0.04. I put this on the side. Okay. So guys, we have to find out the value of the margin of error. The margin of error is denoted by E, and the formula to find the margin of error is Z alpha over 2 square root of P hat and Q hat divided by N. And remember that, note that Q hat is 1 minus P. 1 minus P hat in this case. Okay? So now for our problem, this Q hat is 1 minus, and we already calculated P hat in part A. So 1 minus 0.04, and 1 minus 0.04 is going to be 0.96, I believe. Right, 0.96. Okay, so the most important thing here is, you know the value of P hat, you know the value of Q hat, and you also know the sample size, right? You know the value of N, right? Yes, 4,743. So we need to find the value of Z alpha over 2. So remember that in the previous problem we found the value of Z alpha over 2. We use pretty much exactly same like the same idea to find the value of Z alpha over 2. Okay, so here, so we have to construct the 95% confidence interval, guys. So you note this 95%, so that is the confidence level, and remember that the confidence level is defined as 1 minus alpha, and your confidence level is 95%, and this is 0.95, right? And so you solve for alpha from here. This is 1 minus alpha equal to 0.95. And you solve for alpha, so that's gonna give you 0.05, and you divide both sides by 2, so that will give you alpha over 2 is 0.025, right? Okay, so now you got the value of alpha over 2, so this, the margin of error, you got the value of alpha over 2, and so which is 0.025. Now you have to find out the value of Z alpha over 2, okay? So you got alpha over 2 equals to 0.025. So you need to find the value of Z 0.025, because alpha over 2 is 0.025, and you have a calculator, or you can use any technology, and that value is 1.96. Okay, we did that in part I think like the previous problems. You can use the same idea. Okay, so now let's plug in the value of Z 0.025, Q hat, and the P hat in this formula. So margin of error E is going to be 1.96, which is the value of Z alpha over 2, and square root of, and the P hat is 0.04, 0.04 times the Q hat is 0.96, 0.96, and you divide that by N, and the value of N is 4,743. 4,743. So now you do a little bit arithmetic using your calculator, so you will end up with this number 0. If you round up to 3 decimal places, you will get 0.006. Okay, so this is the margin of error. So this is the final answer for part B. Okay, guys, so this is the final answer. This is the final answer for the part B. Okay, so now let me take you to the part C. So let me erase that. So let me take you to the part C. So the part C is you have to find out the value. So the part C is, I think you have to find out the value. Part C is this, because you are supposed to find out the 95% confidence interval, right? So for the proportion problem, so your 95% confidence interval, 95% confidence interval is given by p hat, right? So minus margin of error is less than p hat plus margin of error. So what is your p hat? And in part A, we found the value of p hat, which is 0.04 minus, and remember that the margin of error we got in the part B is 0.006, right? So now you subtract, margin of error from the p hat, which is 0.006, is less than p. This is the population proportion, right? Is less than, and what is the p hat? 0.04 plus, and the margin of error we found in the part B is 0.006. And now let's do simple math. So that will give you, so 0.034 is less than p is less than 0.046. So this is the 95% confidence interval for this problem. Okay, so this is the final answer for part C. So now, what does that mean? So this means we can conclude, let me write down on the top. So we are almost at the end of the problem, okay, end of the solution, I'm sorry. So what does that mean? So that means one has a 95% confidence, right? So that means one has 95% confidence that the interval from the lower bound, which is, you see, this is the interval, like the interval we have 0.034, this is the lower bound, this is the lower bound of the interval, right, is less than p is less than 0.046, and this is the upper bound, right? So one has 95% confidence that the interval, this interval, actually does contain the true value of the population proportion. The true value of the population proportion. So this is the conclusion, guys. So this is the conclusion. Okay? So let me read that conclusion again. So what does that mean? So this means one has a 95% confidence that the interval is, right, this is the lower bound of the interval and this is the upper bound of the interval, actually contains the true value of the population proportion. Okay, so that's all for today.